Welcome back. Today we are embarking on a deep dive into the architecture of intelligence, exploring the Databricks not just as a platform, but as the foundation for building truly AI-ready data infrastructure. Now, before we start, I would like to set the stage with a critical question that most organizations are getting wrong. In the rush to adopt AI, companies are asking, are we AI ready? When the real question they should be asking is our data AI ready? This distinction matters because you can have the most sophisticated AI tools in the world, and but if the data is not properly architected, governed, and prepared, your AI initiative will fail. Now, over the next few minutes, we will explore how Databricks has architected a platform that does not just solve today's data challenges, but fundamentally rethinks how we should approach data infrastructure in AI first world. Let us begin this journey into the architecture of intelligence. First is first. Let us start with the fundamentals. Yeah, what is Databricks? At its core, Databricks can be understood through three key pillars. First, it is a fully managed data lake analytics platform. This means you can get the flexibility and scale of a data lake without the operational burden. Databricks handles infrastructure, scaling, optimization, and maintenance. You focus on extracting value from your data. Second, it is based on open source technologies. This is crucial and often underappreciated. Databricks is built on Apache Spark, Delta Lake, and MLflow, all open source projects. This means you are not locked into proprietary format or tooling. Your data remains portable, your skills are transferable, and you have the backing of a massive open source community. Third, it is integrated with Azure for resource management and security. This deep integration with Azure means you get enterprise-grade security, compliance, identity management, and resource governance out of the box. It is not a bolted-on solution. It is native integration. But here is what I want you to remember. Databricks is more than the sum of these parts. It is a unified environment for data engineering, machine learning, and analytics. The word unified is going to come up again and again because it is a secret sauce that makes everything else possible. Now, to understand why Databricks matters, we need to understand the revolution that Apache Spark created in big data processing. On the left-hand side of this diagram, you see traditional Hadoop MapReduce, the technology that dominated big data for years. Notice the workflow. You read from the HDFS, run a mapper step, write results back to HDFS, then run a reducer step and write final result back to HDFS again. Every single step involves disk I/O. Read from disk, write to disk, read from disk, write to disk. For large data set, this becomes an enormous bottleneck. Your CPU sits idle waiting for this disk operation. This is why MapReduce jobs could take hours, even days, to finish. Now, look at the right side, Apache Spark's approach. Instead of constantly writing to disk, Spark introduced in-memory processing. Data is loaded into RAM across your cluster, and transformation happens in the memory. Only the final results are written back to storage. The performance difference is staggering. Spark can be 100 times faster than MapReduce for certain workloads. But it is not just about speed. It is about enabling real-time analytics, interactive data science, and complex multi-stage pipeline that would be impractical with MapReduce. This is a foundation that Databricks is built on, and the Databricks team knows this technology properly and in details because they have created it. Now, this slide shows how Apache Spark architecture works within Databricks. At the top, you have the head node with two critical components. The driver program, this is where your code runs and where execution plans are created. And then you have the Spark context. This manages the connection to the cluster and coordinates the distributed execution. In the middle, you have the cluster manager. Think of this think of this one as the orchestrator. It allocates resources, monitors health, and ensures work is distributed efficiently across work nodes. At the bottom, you have worker nodes. This is where the actual computation happens. Each worker has cache, in-memory storage for fast data access, tasks, units of work assigned by the driver. They all read from HDFS, or in Databricks case, from Delta Lake on object storage. Here is what is powerful about this architecture. As a developer or data scientist, you write code as if you are working with data on a single machine. You use familiar APIs like Python, SQL, Scala, R, and then Spark and Databricks handles all the complexity of the distribution that work across dozens of or hundreds of nodes. You don't need to be a distributed system engineer to process terabytes of data. You just need to know your domain and your language of choice. The platform handles the rest. This abstraction is what makes Databricks accessible to data teams of all skill levels. Now, let us talk about the people behind Databricks because their background is crucial to understanding why this platform is so powerful. This Forbes article from 2021 tells the story of the accidental billionaires, the 7 academics who created Apache Spark and went on to found Databricks. These are not just entrepreneurs who saw a market opportunity. These are the researchers from UC Berkeley's AMP lab who fundamentally reimagined how distributed data processing should work. They created Apache Spark, they created Delta Lake, and they created MLflow. And what is remarkable is that they didn't just create the technology and hand it off. They built a company to produce this Databricks and support it. This means when you are using Databricks, you are not using someone else's implementation of Spark. You are using the platform built by the people who invented the underlying technologies. This matters because the depth of understanding shows in every aspect of platform, from performance optimization to architectural decisions to the product roadmaps. They are not chasing trends. They are defining the future of data and AI infrastructure based on deep computer science research. This is why Databricks has been able to stay ahead of competitors and why their innovations tend to become industry standard. Databricks serves 3 primary personas, and understanding this is a key to appreciating the unified nature of the platform. Data engineers, they build and maintain data pipelines, implement data quality checks, manages data transformation, and ensures data flows reliably from source system to consumption layers. In Databricks, they use Delta Live tables, PySpark, SQL, and orchestration tools. Now, the data scientists, they explore data, build predictive models, run experiments, and deploy machine learning solutions. In Databricks, they use collaborative notebooks, MLflow for experiment tracking, and have access to GPU clusters for deep learning. And the data analysts, they query data, create visualization, build dashboards, and deliver insights to business stakeholders. In Databricks, they use SQL Analytics, can create dashboards, and increasingly use AI, BI tools like Genie for conversational analytics. Here is what revolutionary in traditional organizations, these three personas work in completely separate tools. Engineers in Airflow or custom ETL frameworks, data scientists in Jupyter Notebook or SageMaker, analysts in Tableau or Power BI. This creates friction. Data gets copied between systems. Different versions of truth emerge, and the collaboration requires constant context switching. Databricks unifies all three personas in one platform on the same data with shared governance. An engineer can create a pipeline. A data scientist can immediately use that data to build a model, and an analyst can query both the raw data and model prediction, all in the same environment. This isn't just convenient, it is a fundamental shift in how data teams operate. Let us take a step back and look at what this diagram is really showing us. This isn't just another data architecture slide. It is Databricks explaining how data analytics and AI now come together in one platform. Now, on the left, you see the reality of enterprise data. Databases, logs, files, sensors arriving in both batch and streaming. Databricks handles this through a Lakeflow Connect and Autoloader, so data is continuously ingested without building fragile custom pipeline. Now look at the center. This is the key idea. Instead of using separate platform for ETL, SQL, machine learning, and AI, Databricks runs all the workloads side by side. Data engineers use Spark and Photon. Analysts use Databricks SQL, and the AI teams built with Mosaic AI, all on the same data without duplication or movement. This is why Databricks call it as a data intelligence platform. The platform does not just store data, it understands how data is used through AI functions, assistants, and predictive optimization built directly into the engine. And now, governance is also applied once using Unity Catalog. The same access control, lineage, and policies apply to tables, files, models, and AI workloads, which is essential for enterprise and regulated environments. Data itself is organized using the medallion architecture: bronze for raw data, silver for cleaned and validate data, and gold for analytics and AI-ready data, all built on open format like Delta Lake. On the right, this data powers dashboards, applications, and AI-driven experience like Genie, while Delta sharing enables secure data sharing across teams and partners. Yeah. So the takeaway is simple. Databricks is no longer just a Spark platform or Lakehouse. It is positioning itself as a unified data and AI operating system. Governance is once built on open standard and designed for AI era. This is another Databricks diagram which explains the core idea behind modern data platform. At the foundation, you have an open data lake, open format, scalable storage, and no vendor lock. So, but raw data alone is not enough. All the center is the key shift, unified data combined with a unified governance. This means the same data is used everywhere and the same rules apply everywhere as well, which means security, access control, lineage, and compliance are enforced once, not reinvented for every tool. Sitting on top of this foundation is the data intelligence engine. This is what connects data to real outcome. From the same governed data, the platform supports business intelligence for dashboards and reporting. Data warehousing for analytical workloads, ETL and the real-time analytics for pipeline and streaming, AI and data science for machine learning, and generative AI and orchestration to automate and coordinate everything, all without copying data or breaking governance. The message is here is simple but powerful. Instead of a separate system for BI, data engineering, and AI, everything runs on one intelligent layer, powered by shared data and shared governance. Now, think of a Databricks platform as a house built on your data. At the foundation, your data is stored in open lake format, accessible, interoperable, and not locked into a single tool. And the first critical layer is Unity Catalog. This provides, as we said before, a single source of governance, covering security, access control, lineage, and compliance across all data, analytics, and AI workloads. On top of that sits the knowledge of your data, metadata, context, and understanding that turns raw data into something intelligent and usable. From this shared foundation, Databricks support Lakeflow for ingestion, ETL and streaming, Databricks SQL for data warehousing, AI BI for analytic and reporting, and Mosaic AI for building intelligent and generative AI application. The key idea is simple: one open data foundation, one governance layer, and multiple workloads all working together through a single data intelligence platform. Now, before we go deeper into capabilities, I want to pause on the critical question that should be driving every data and AI initiative. Is your data AI ready? We know the platform, Databricks platform, is AI ready, but what about the data, the one which is sitting inside this platform? Because the platform is one thing, the data inside the platform is another one. So the question should be, is your data also AI ready? This question is more important than what AI tools should we use or which LLM should we adopt. Because here is the uncomfortable truth. You can deploy the most sophisticated AI platform on the market and still fail if your data isn't ready. What does AI-ready data look like? One is quality. Your data must be accurate, complete, and consistent. So AI amplifies whatever is in your data. If your data has quality issues, your AI will have quality issues at scale. Now, governance. You need to know where data comes from, who can access it, and how it is transformed, and also what that it means. Without governance, you cannot trust your AI outputs or comply with the regulations. Context, metadata, lineage, and documentation are crucial. AI system need context to function properly. What does this field mean? How was it calculated, or what are valid values? Now, the other one is accessibility. Data scientists and engineers need to be able to find, understand, and use data without waiting weeks for access approval or data engineering work. Another one is that velocity. In the AI era, data pipelines need to deliver fresh data quickly. Stale data means stale insight and stale models. Yeah, Databricks provide the infrastructure for AI-ready data, but you need to actually implement the practices that makes your data AI ready. The platform is the foundation. Your data strategy is what builds the house. So the question is always, is your data AI ready? This should be your North Star as we explore the capability that follows. We saw previously how Databricks resolved the data processing uh, issues by giving us this Apache Spark. Now we are going to look at another solution which was given to us by Databricks, which is the Lakehouse. So before we start looking at the Lakehouse, though, we need to see a little bit what was before the Lakehouse, especially these two big elements, which was dealing with data warehousing solution, was data lake and data warehouse. Now, first, though, let us examine the legacy data lake architecture and why it falls short for AI workloads. Data lakes emerged in 2010 as a solution to data warehouse limitation. The premise was compelling: store all your data in cheap object storage in its native format and figure out how to use it later. Schema on read became the mantra. The strengths are real, though. Store any kind of data, structured tables, JSON logs, images, videos, PDFs, audio files. Yeah. So it also provides, the data lake was also providing inexpensive storage. Object storage is dramatically cheaper than warehouse storage. It was a good starting point for data science and machine learning. It supports for generative AI use cases and the streaming application. But the downside proved devastating in practice. It was very complex to set up properly. You need data engineers to build custom framework for everything. And now Power BI performance, again, without optimization, query performance is slow. Data swamp, which is the critical part, which is very problematic for data lake. These data swamps, without governance, data lakes become dumping grounds where data quality erodes. You still need, because of that, you still need a warehouse. So for production analytics, you end up building a warehouse anyway. So the fundamental issue is like data lakes prioritized flexibility over reliability. This works for exploratory work, but fails for production systems. For AI specifically, data lake have a critical flaw. They don't provide the data quality guarantees that AI systems require. If you train a model on data lake where yesterday's data is different from today's data because someone changed the schema, your model breaks. Now, this is why pure data lake approaches have not scaled for enterprise AI. You need reliability, flexibility, which is what Lakehouse does. Now, let us look at the other side, the legacy data warehouse. Data warehouse have been the gold standard for analytics for decades, and for good reason. Their strengths are substantial. Yeah. So purpose built for, the data warehouse is purpose built for BI and reporting, as we know. Query performance is optimized for analytical workload. It was meant to unify disparate systems. They provide a single source of truth, structured, clean data with standardized schemas. Data quality is enforced. Excellent query performance for SQL, and the analytic is fantastic. So, but in the AI era, the limitations are crippling. No support for the data warehouse, that is, yeah. There is no support for semi-structured or unstructured data. Good luck loading PDF if you're working on this data warehouse. So to load PDF, how painful was it? Yeah. Images is also problematic to load, or streaming JSON into traditional warehouse. So all this stuff are problematic. So there is poor support for data science, AI, and streaming. These workloads were not part of the original design. And it was also closed proprietary format, which is, if you know, you cannot, if you're working in Oracle, you cannot, the same thing cannot do it in SQL or MySQL or any database for that matter. So it is closed proprietary format and vendor locked in real, and therefore, if you want to migrate data, it's very painful, expensive to scale as well. As data volumes grow, cost skyrockets. Yeah. So you need to buy another server, another system, as it were, if you want to, if the volume increases. So here is the AI specific problem, though. Modern AI application need access to unstructured data, documents for RAG systems, images for computer vision, audio for speech models. Traditional warehouse cannot handle this kind of need. So even for structured machine learning use cases, warehouses are problematic. Data scientists want to iterate quickly, experiment with features, and version their data set. So warehouse schemas are rigid, and changes require formal change management process. So now the warehouse approach worked when analytics meant SQL queries on structured data. But in 2025, for example, analytics include machine learning models, real-time predictions, vector search, and LLM applications. So warehouses were not built for that world. Yeah. So this Lakehouse architecture solved this by providing warehouse class performance on lake-style storage. So here we are. This is the Lakehouse solution, which was provided by Databricks. Now, the Lakehouse represents the synthesis of data lakes and data warehouses, combining the best of both worlds. Think of it this way. What if you could take the cheap, flexible object storage of a data lake and add the reliability, performance, and governance of a data warehouse? That is the Lakehouse. Here is how it works. The foundation data is stored in object storage like S3, ADLS Gen 2, UCS, in an open format like Parquet. Now, this is a key part. So the data is stored in this Lakehouse, yeah, the data lake, sorry, the data lake as usual, which is the AWS S3, ADLS Gen 2, or GCS, yeah. But here is the key part. It is stored in open Parquet file. So this is the breakthrough. So this gives you data lake economics, yeah, because it's stored in storage. Now the transaction layer, the delta lake, not the data, the delta lake adds a transaction log on top of that storage. This log provides, yeah, ACID transitions, so reads and writes don't conflict. Schema enforcement, so data quality is maintained. Time travel, so you can query historical version. Metadata for performance optimization, and the performance layer, which optimizations like Z ordering, data compaction, and liquid clustering give you warehouse class query speed on the lake storage. And also another one is the governance layer. Unity Catalog provides centralized governance, access control, and the lineage across all your data. The result, one platform that supports SQL analytics with warehouse class performance, machine learning with full access to structured and unstructured data, real-time streaming with exactly one's semantics, BI dashboards with sub-second query times, and generative AI application with vector search and RAG. All of this is on the same data with consistent governance using open format that prevents lock-in. So this isn't a compromise between lakes and warehouse. It is a fundamentally better architecture that makes both traditional approaches obsolete. This is why Lakehouse adoption is accelerating. It is not just incrementally better; it is categorically different, and it makes a breakthrough, and it is now adopted by every main vendors in the market. Now, this is the same thing, but in a different format. This is the Lakehouse architecture, Databricks answer to the data platform dilemma. The Lakehouse sits at the intersection of data warehouses and data lake, taking the best of both while eliminating their weaknesses. Yeah. So this is the key part. That's why I brought this diagram here, because it's taken from both worlds, the best of both worlds. Yeah. From data warehouse, the Lakehouse takes a seed transaction for data reliability, schema enforcement for data quality, optimized query for performance analytics, and then time travel and versioning for audit and compliance. And from data lakes, the Lakehouse takes low-cost object storage like S3, ADLS, and JCS, support for all data type, structured, semi-structured, and unstructured, flexibility for diverse workloads, open file format like Parquet. This innovation is Delta Lake, an open source storage layer that sits on top of object storage and provide database-like capability through a transaction log. Notice what this architecture enables. Yeah, all machine learning, SQL, BI, and streaming use case run on the same data. One security and governance approach for all data assets, yeah, and one platform that works across all clouds, an open and reliable foundation that handles all data types. You are not maintaining separate system or copying data between warehouse and lakehouse. Everything lives in one unified layer. The implications are profound: faster development, lower cost, better governance, and true collaboration across data teams. This is the architectural foundation that makes everything else we will discuss possible. And therefore, Delta Lake, Delta, not data, the Delta Lake solves this through a transaction log. Every change to a delta table is recorded in JSON files that form an atomic ordered log of operations. When you write to a delta table, Delta writes new Parquet file to storage. Delta appends a commit to the transaction log. Only after the commit succeeds is the write visible to readers. Now, readers always see a consistent snapshot of the data. Concurrent writers don't conflict. Failed operation leave no corrupt state behind. This is the foundation for everything else. If you cannot trust your data at the storage layer or storage level, nothing built on top of it is trustworthy. So, ACID transaction makes the Lakehouse reliable enough for production AI systems. This slide shows the architecture of a unified intelligence platform, how it all pieced together that we have discussed fit together into a cohesive system. At the bottom, you have your data sources, IoT devices, like applications, database, files, streams, data flows into the Lakehouse. the storage layer. All data lands in Delta Lake tables, your unified foundations, whether it is structured tables, semi-structured JSON format, or unstructured files, it's all lives in Delta format and object storage. Now, the processing layer, the Databricks processing engine, handles all workloads: batch processing for large-scale ETL, stream processing for real-time data, SQL analytics for BI queries, ML training for model development, vector search for semantic retrievals. Now, the other side is like the one component, one very important component of Databricks is the Lakeflow. We'll come to this one in much details how it works. It has three parts to it, like the Lakeflow Connect, it has also the pipeline itself and the scheduling. So we'll come back to this one, but let us see what is trying to answer this one in Databricks. Yeah. So the answer to a critical missing piece is like the operational layer. This Lakeflow is the operational layer between storage and consumption. In traditional architecture, you have storage where data lives, compute where data is processed, but there is a gap. How do you reliably move data from point A to point B with the quality guarantees? This gap is where data engineering teams spend 70% of their time writing ETL code, handling errors and retries, monitoring pipeline health, ensuring data quality, managing dependency, optimizing performance. But Lakeflow democratization is this operational complexity. It provides declarative pipeline, which is a breakthrough. This is a declarative pipeline. You declare what you want. So this table with this transformation, and not how to build it, when to run it, how to parallelize, how to handle failures. Yeah, just you see what you want, and then the system will do it for you. So this is the declarative pipeline. So it has automatic quality, data quality expectations are first class construct there. You don't need to do first load them and then do data quality. They are part of this Lakeflow. You define them alongside your transformation, and the Lakeflow enforces them automatically. Now, dependency management. Lakeflow analyze your pipeline definitions and automatically determine the right order of execution, parallelization opportunities, and refresh strategies. Now, self-healing. When error occurs, Lakeflow automatically retries with back off, guaranteeing bad data. It quarantines bad data and alerts you to issues. Now, the other one is like observability, which is built-in monitoring. It shows you data quality metrics, pipeline performance, and the lineage without custom instrumentation. So the missing link here is Lakeflow provide is making production data engineer accessible to teams beyond specialist data engineering. So an analyst who knows SQL can build production grade pipeline. A data scientist can create feature pipeline without becoming a Spark expert. This democratization is crucial because the bottleneck in most organizations isn't compute or storage. It is a specialized knowledge required to build reliable data pipeline. Now, this is Lakebase. Lakebase is the newest addition to Databricks platform and also the most important one as well. It is very new and it fills a gap. Fills a very long-standing gap because all these data warehouses or solutions were optimized for analytics, yeah, and they were not optimized for operational data, and therefore the operational data were not like part of a solution within these platforms. So Databricks brought this operational data, Postgres compatible data, which is which is actually a serverless compute system to deal with operational data, which is going to support the AI natively, and therefore is going to have it is going to separate compute and storage, giving you elasticity at scale. We'll come back to that one in much details when we are going to look at this one, and especially the how do we implement the operational side into Databricks. One of the important components of Databricks is the Mosaic AI, which represents Databricks' bet on the future of artificial intelligence. These compound AI systems and agents. Now, this is a breakthrough when you compare all the AI systems in the market. Yeah, so Databricks solution is slightly different and from other systems. We are going to come to that one in much details when we try to compare Databricks solution, which is Mosaic AI, with the Snowflake, the Cortex AI, and also with Azure Foundry as well. So we'll come to that one in much details. But what we want to say here is like it is like Mosaic AI, where AI solution is a first-class citizen in Databricks. Yeah. So what the evolution of AI application, which is from 2015 to 2020, single model prediction. This email is a spam. This transaction is fraud. This was what was happening in the until from 2015 to 2020. This is AI applications. They were meant to do like a single model predictions. Yeah. Now 2023 came like this multiple model in pipelines, like detect objects, then classify them, then recommend action. Yeah. So 2023, 2025, this was like the compound AI systems combine LLMs, retrieval tools, and agents. So Mosaic AI provides infrastructure for building these sophisticated systems. Vector search, built-in vector database for semantic similarity. You can create embeddings from your delta tables, search by meanings, not just keywords. Now, Power RAG, retriever augmented generation applications, all with the same ACID guarantees and governed as regular tables. Now, this is a key part here now. Databricks has LLM fine-tuning, takes open source models and specialize them for your domain. This is a big change, and it requires a very sophisticated knowledge as well. So you have it in Databricks. So you have this fine-tuning, and the infrastructure supports that kind of exercise in Databricks. So use your proprietary data as a training data. Yeah, create models that understand your terminology, processes, and context. So deploy them securely within your environment as well. So the AI gateway, managed infrastructure for LLM calls, rate limiting and cost management, usage tracking and monitoring, multiple LLM provider support, caching for performance and cost optimization. Yeah, so you can name it. I mean, agent framework, build AI agents that can use tools, call APIs, query database, run code. Yeah. Now, chain multiple steps to accomplish complex tasks, learn from feedback, operate within guardrails, and you define. So the key innovation, all of this is built on the same Delta Lake foundation, governed by Unity Catalog, tracked by machine ML flow. Your AI application are not bolted into your data platform. They are native part of it. So this means your AI system have the same reliability, governance, and lineage as your traditional data pipeline. No special cases, no separate governance, no data silos. This is how you build production AI systems. Now, this is AI BI with Jenny represents the fundamental shift on how business users interact with data. Now, traditional BI, what you do is like analysis, write SQL query, or build dashboards in tools like Tableau or Power BI. Now, business users consume pre-built dashboards, but cannot easily explore data themselves. If they have a new question, they need to request new dashboards from analysts. Yeah, the bottleneck here is analyst team become overwhelmed with ad hoc requests. This is again experience. If a person is analyst, he would have felt this request. I mean, multiple requests and people needing like data. If you can change this one for me, if you can add this one, I want this data set. Yeah, the data quality is wrong. Can you do this one for me, and so on and so forth. So I don't like this kind of report. Can you change it as well? So the data analyst will be overwhelmed with ad hoc requests. So business users also get frustrated waiting for answers. Insights are delayed by weeks. So Jenny changes this through conversational analytics powered by LLMs. Yeah. So in here, the natural language queries, business users can ask questions in plain English. What were our top selling product last quarter, for example? Show me customer retention by region. Compare this month's revenue to last year. Now, automatic SQL generation. Jenny also understands the question, determines which tables and columns are needed, generate optimized SQL, execute the query, present results with visualization. Now, what about that? Context awareness. Jenny knows about your data schemas and relationships, business definition and metrics, historical queries and pattern as well, users permission and access control. Now, and also it is governance integration because Jenny operates through Unity Catalog. Users only see data they are authorized to access. All queries are logged and auditable as well. Data lineage is maintained. Governance policies are enforced. The implication is business users get answers in seconds, not weeks. Analysis focus on complex analysis, not repetitive queries. More people can make data-driven decisions, faster time for question to insight. So this democratization, not just data engineers, Lakeflow, but also data analysis. Yeah, the barrier to getting insight from data drops dramatically. Importantly, though, this isn't a separate tool. It is built into the Databricks platform, querying the same Delta tables, governed by the same Unity catalog, unified platform, unified experience. Now, the big innovation of Databricks, this Unity catalog, it is a breakthrough to have this Unity catalog. It is the governance backbone that makes the entire Databricks platform trustworthy and scalable. Here is the challenge that Unity Catalog solves. In traditional data platform, governance is fragmented. Now, one system governs tables, another governs files, another one governs ML models, another governs features, security is managed separately, lineage is tracked in a different tool, metadata is scattered across systems. Can you see? This fragmentation creates massive problems. Compliance teams cannot get a complete picture. Data teams waste time reconciling permission. Lineage is incomplete or wrong. Discovery is nearly impossible. Audit trails have gaps. Now, the Unity catalog unifies all of these, centralized metadata, one catalog for tables, views, files, modules, features, and functions across all workspace and clouds. Now, there's also fine-grained access control, grant permission at any level, catalog level access to entire data domains, schema level access to groups of tables, table level access to specific data sets, yeah, and also column level access to specific fields, row level access to specific records based on attributes. Now, and also you have this data lineage, automatically track where data comes from, which is source system, how it is transformed, pipeline logic, where it is used, BI dashboard or machine learning, yeah, and models, applications, who accesses it and when. And also you have data discovery, which is very critical here. Users can search for data set across the organization, understand what data contains through AI generated description, see quality metrics and freshness, request access through self-service workflow. Yeah. So, and also you have this audit logging, complete audit trail, who accesses what data, and also and so on and so forth. So there is a plentiful of solutions within this data or this unit. Now, one of Databricks' most strategic decisions is it is commitment to developer freedom and open standard. This slide explains why this matters, because the lock-in problem, many data platforms use proprietary format, APIs, and tools. Once you are in, migration is painful or impossible. Vendors know this and can charge accordingly. So Databricks open approach is like open storage format. Delta Lake is built on Parquet files. Your data is readable by any tools that understand Parquet. If you leave Databricks, you take your data with you. No conversion needed. And it's open APIs like Spark API are open source and standardized. MLflow API work across platform. REST API for programmatic access. You have JDBC, ODBC for SQL connectivity. Yeah. So you have open source projects like Apache Spark, Delta Lake, and Machine MLflow, Unity Catalog. And why this matter? Because developers' freedom, your team learns portable skills, Spark, SQL, Python, MLflow, knowledge transfer to other platform and companies. You are not locked into a proprietary DSL or tools. So this is a breakthrough in data warehouse. Now, a third component of Databricks is this MLflow, which is like a product which has been given to the developers community by Databricks. MLflow is open source platform for managing the complete machine learning lifecycle. The ML machine learning lifecycle challenge, which is building a model, is maybe 20% of the work. The other 80% is tracking experiments. What hyper parameters did we try? What results did we get? Reproducibility. Can we recreate this model? What code version? What data? What environment? Model packaging. How do we deploy this across different environment? Version management. What models are in production? What are like staging? Deployment. How do we serve predictions? Batch, real-time streaming, monitoring. Is the model performing well in production? Is it drifting? So MLflow addresses all of this through 4 components. One is MLflow tracking. It automatically logs parameters, metrics, and artifacts. Every experiment run is recorded with full context. Compare runs visually to find best models, store code versions, data snapshots, and environment config. And the second one is MLflow project, which is package ML codes in reusable, reproducible format. Define dependencies and environment requirement, and run anywhere, which is local, cloud, or Kubernetes. Share with team members reliably. And then the third one is MLflow models, a standard format for packaging models, work across a framework, yeah, and includes metadata, schema, dependency, signature, deploy to multiple targets. And the fourth one is MLflow model registry, which is very important here, a centralized repository for model version, lifecycle stages like staging, production, archived, approval workflow for production deployment, lineage, track which data and code produces each model. So the integration with Databricks, tracking happens automatically in notebooks. Yeah, this is the key part here now. Models registered, the models registered in Unity Catalog have full governance. Yeah. Now, deployment to Databricks endpoint is one click. Monitoring integrates with the platform observability. But here's the key. MLflow is open source and portable. You can use it on any platform with any infrastructure. This means skills are portable, you are not locked in, and then your ML work is reproducible outside Databricks as well. This is the same philosophy as Delta Lake and Unity Catalog, open standard that Databricks implement excellently, but does not monopolize. That's Now let us talk about this competitive landscape, because Databricks does not exist in a vacuum. So we'll try to compare three major approaches here. And one of the main competitors, and I think one of the key players on the data warehousing is Snowflake. This is the cloud environment we're talking about. So Snowflake is the leading and the best of breed cloud data warehousing. The key part is like cloud data warehousing is the Snowflake is the leader. It has a specific strength which you don't see in other places, or they are excellent on Snowflake. For example, they are exceptional query performance. It is simple, intuitive user experience, near zero administration. It is also excellent for SQL analytics and BI. It has a very strong marketplace for data sharing as well. Now, there are a couple of things which are they are not Snowflake kind of thing. Like for example, in terms of machine learning, it's less mature, and the AI loads also is not mature. Streaming support is also very basic, and the data science experience is not integrated. But now it's changing as well. They are just copying, they are just fastly moving. But there is like still they are not like the leaders on that side. So you can become so again, another one is like their system can be very expensive at scale, and there is less control over infrastructure because it is tightly controlled, especially the infrastructure. The Snowflake control most of it, and therefore you don't have that much control on that side. So that's Snowflake side. So they are the leading in cloud data warehouse, though. That's the key part. On the AI side, um, they don't do like a lot of AI in terms of like for agentic AI and so on. They are more on the analytics side. So they have created like purpose-built analytic AI, which works very good in secure data, and therefore on that side they are excellent. But if you want to build like agentic AI or like fine tuning and so on and so forth, it is not that matured. Yeah, so that's the key part. So it is by design. They don't deal with that kind of fine tuning or AI experience that much. So their AI is geared, the Cortex AI. It is meant to be for analytics. Yeah, they are very good in analytics side. So they are built. The AI is built in SQL. That is, yeah. Now, so they are best for analytic first organization where SQL queries and BI dashboard are the primary use cases. Yeah. Now, the Databricks, on the other hand, the Lakehouse platform, its strength is a unified platform for data engineering, data science, and analytics. Now, the key part is built for AI from ground up, excellent machine learning capabilities with ML flow, strong streaming support as well, more cost effective for large scale workloads. So, and also it is open source foundation. Its limitation is the steeper learning curve, requires more data engineering expertise. PI tool is not as mature as Snowflake. Yeah. So best for organizations where data strategy is AI strategy. Yeah. So if your strategy, your data strategy is AI strategy, so Databricks is for you. And also you need a unified data engineering and machine learning. So the other side is like the one in AWS and Azure, the Fabric one, yeah. So these are like maximum flexibility and control. They are native cloud integration. They are more built for Azure or AWS. Can cherry pick best of breed services, often cheapest on pure infrastructure costs, no vendor lock in so to a platform. So the limitation here is you become the integrator, requires substantial engineering effort, complex to operate and maintain, now fragmented governance and higher tool costs of ownership due to engineering time. So the best for organizations with large, sophisticated data engineering teams who want maximum control. Again, let me say that they are slightly different. For example, if you want like a more secure, controlled AI solution, then Azure Foundry is the best because what they do is like they spend a lot of time creating like a secure environment. So you don't have much flexibility. Microsoft like will take that control, but you will get like a secure environment. So they have like solutions on that side. But if you want to be like, if you want to build your own, so Azure is not good for you. It is Databricks will be the best solution in that sense. Yeah. So the strategic choice is choose if you are Snowflake, if primary need is SQL analytics and BI. So if you need SQL analytics and BI, Snowflake is for you. If you need choose Databricks if AI and machine learning are central to your data strategy. Yeah? Choose the other like AWS and Azure if you have the team and expertise to build and maintain custom solutions. Yeah. So that so this slide addresses a critical strategic question: integration with best of breed. Yeah. Should you choose an integrated platform like Databricks or assemble best of breed point solution? The best of breed argument is like choose the best tool for each job, like use Snowflake for data warehousing, use Airflow for orchestration, use SageMaker for machine learning, which is AWS solution, use Kafka for streaming, use dbt for transformation, and use custom tools for governance. Yeah. So theoretical advantage, flexibility to choose best tools for each use case, avoid vendor lock-in, and leverage innovation across vendors. But the real world problem is integration complexity, like making 10 tools work together is hard. Yeah. Data duplication. Each tool needs its own copy of data. And governance, also fragmentation, different permission models everywhere, multiple vendor relationship, like a separate contracts, support pricing, skills proliferation, like teams need expertise in main platform, higher total cost, integration and maintenance costs exceed savings. So the integrated platform argument, like the Databricks one, use one platform for all the data and AI workloads, Lakehouse for storage, Lakeflow for data engineering, and Databricks SQL for analytics, MLflow for machine learning, Mosaic AI for genetic AI. Unity catalog for governance. Yeah. So advantages is a unified data, one copy serves all purposes, unified governance, one permission model, unified skills like team expertise, compounds lower operational complexity, one platform to manage, and also better performance, no data movement between systems, and faster development, no integration code needed. Yeah. So you need to do trade-offs. Some platform dependencies, less flexibility for niche use cases, one vendor relationship, risk and benefit as well. So you need to look at it from different angle. Yeah. So the strategic critic is best of breed made sense when tools were truly specialized, integration was simple, data volume was smaller, team or larger. In 2025, though, integrated platform makes sense when data volumes are massive, data movement is expensive as well, governance is critical, fragmentation is risky, teams are lean, complexity is costly, speed matters like integration time is opportunity cost, and AI strategic, which is a unified data and machine learning is essential. So the market is choosing integration. Databricks, Snowflake, and Cloud Platform are all moving towards integrated solutions because best of breed complexity tax is too high. The question isn't can we integrate these tools? It is our time better spent integrating tools or delivering business value? I'm going to come to this slide later on the series, but just to summarize, the business case for Databricks. When you want to choose Databricks, it should have it should add value to what you are doing, and therefore there is three elements which I'm going to add here: total cost of ownership, velocity, and feature proofs. And therefore, we'll look at it at a different time and when we have done much work on Databricks. Yeah. Now, let us build something here. So we have covered a lot of ground today. Let me bring it all together. The architecture of intelligence is not just about technology. It is about making a strategic choice how you will compete in an AI-driven world. Here's what we have learned in this session. The problem is traditional architecture force false choices between flexibility and governance, between lakes and warehouses, between data engineering and machine learning. The solution, the Lakehouse architecture, eliminates this trade-off through a unified data, unified governance, and unified processing. The foundation is the Delta Lake provides ACID transaction, which is an object storage, making data lakes reliable enough for production AI. The platform is Databricks provide integrated capability for data engineering, which is Lakeflow, analytics, which is SQL plus AI BI, machine learning, and also MLflow and generative AI and using Mosaic AI, all on the same data foundation. And they have the governance, which is Unity Catalog provides a governance backbone that makes a scale possible without sacrificing speed, and the philosophy. It is open standard and developers freedom, mean your investment is portable, your team's skills are transferable. Yeah. But here is what I want you to remember most. Databricks provides infrastructure for AI ready data, but you have to make your data AI ready. This means investing in data quality and governance, building reliable pipeline with testing, maintaining rich metadata and context, creating a culture where data is a shared asset. Yeah, continuously monitoring and improving data systems. The platform is powerful, but your practices and people makes it the difference. So I will leave you with the question we started with: is your data AI ready? If the answer is not yet, or I'm not sure, that is okay. Recognition the first step. The path forward is clear: unified data architecture, a strong governance, declarative pipeline, and the commitment to data quality. I am Ahmed Mahmoud from DataMind AI, and my mission is to help organizations turn their data into decision-ready intelligence. Whether you are starting with Databricks or looking to optimize your existing implementation, the journey to AI-ready data is one we can take together. Let us build something extraordinary. Thank you very much.